Let us revise our first chapter, sets. In this page, you can see a question. Question number 1. Set x such that x is a prime number less than 10. Okay, so to solve this problem, we have to understand what the prime numbers are. See, numbers 1. How can you split 1? 1 can be expressed as a product of 1 and 1, or 1 into 1 equal to 1. Then what about 2? 1 into 2. Okay, so factors are factors are 2. Factors of 2 are what? Only 1 and 2. 1 and the same number. Factors of 1 are only 1. Okay, so 1 is the only factor of 1. 1 and the same number are the factors for 2. Similarly, factors of 3, 1 into 3, 1 and 3 are factors of 3. But when we consider 4, which are the factors? 1 and 4, because 1 into 4 equal to 4. Similarly, 2 into 2 is always also 4. So factors of 4 are what? 1, 2 and 4. Factors of 5, 1 and same number. Okay, factors of 6, 1 and 6. 1 into 6 is 6. 2 into 3 or 3 into 2 equal to 6. So factors of 6 are 1, 2, 3 and 6. So we take these numbers, tick mark number 2, 3, 5, etc. These numbers have factors 1 and the same number. For 2, 1 and 2 are factors. For 3, 1 and 3 are factors. For 5, 1 and 5 are 1 and the same numbers are factors. Such numbers are called as prime numbers. So which are the prime numbers less than 10? Yes, definitely 2, 3, 5, similarly 7, only 1 into 7, 7. Okay, 9 is not prime number because what? 9 can be expressed as 1 into 9, and similarly 3 into 3, 3 into 3 is also 9, so 9 cannot be included. Okay, so which are the prime numbers less than 10? 2, 3, 5, 7. So such numbers are called as prime numbers. Prime numbers are the numbers whose factors are only 1 and the same number. Okay, so here answer is 2, 3, 5, 7. Similarly, consider the second question. 2. Set x such that x belongs to n. 2 less than or equal to x less than 5. So when we consider a number line starting from 0 and 1, 2, 3, 4, 5, 6, etc., etc. Here minus 1, minus 2, etc. Okay, but in this question x belongs to n. N means natural number, so 0 is not included. You can start from this 1 onwards. 1, 2, 3, 4, 5, 6, etc. These are the natural numbers. 0 cannot be included here. Okay, so which are the natural numbers in between 2 and 5? Here 2, here 5, but there is an underscore less than or equal to, so 2 is needed to be included, and 2 is included here. 3, 4, but there is no underscore for this 5, so below 5, less than 5, 5 is not included. So which are the natural numbers? 2 less than or equal to x less than 5. Yes, clearly 2, 3 and 4. 2, 3 and 4. Okay, and so similarly x such that x belongs to z. Minus 2 less than or equal to x less than 3. Here set means integers. Integers, set of integers means what? The numbers of the form negatives, positives and zeros. No decimal numbers are included here. These are the set of integers. Okay, so minus 2 less than or equal to x means minus 2 is included. Okay, and less than or equal to 3, 3 is also included. So in between minus 2 and plus 3 both are included. So answer is what? Minus 2, minus 1, 0, 1, 2, 3. minus 2, minus 1, 0, 1, 2, 3. So that is all about these three questions. Say question number 4, x such that x is an integer 1 by 2 less than x less than 9 by 2. So when we draw a number line, 1 by 2 means half is here, okay. 9 by 2 means half of 9 means 4.5 is here. So in between 1 by 2 and 9 by 4 means what? These are the numbers, and integer means no decimals are counted. Integer means complete number. So 1, 2, 3, 4. Okay, so this set is what? 1, 2, 3, 4. Right. So that is all about this question. Then see question number 5. Set x such that x belongs to R, comma x square minus 4 equal to 0. So we have to solve this quadratic equation, ax square plus bx plus c, or simply we can write this one as x square minus 4 equal to 0. That is x square minus 4 equal to 0. We have to find the value of x. Then x square is equal to 4. This minus 4 is transposed to the right side. So x square is equal to 4. X is what? Square root of 4, whose answers are plus 2 and minus 2, because 2 square is 4, minus 2 whole square is also 4. So there are two answers, plus 2 and minus 2, or minus 2 and plus 2. So these are the values for x, and these values are categorized as a set. Therefore set x such that x belongs to R, x square minus 4 equal to 0 is expressed in the Rorschach form as minus 2 comma 2. Right. Then what about this question? X such that x belongs to R, comma x square minus 5x plus 6 equal to 0. Purely this is a quadratic equation, and this equation is of the form ax square plus bx plus c equal to 0, and the value of x can be calculated as minus b plus or minus root of b square minus 4ac whole divided by 2a, and hence answer will become 2 comma 3. That is very known for you. So this formula was understood from your 10th standard. And another easy way, we can factorize this quadratic equation as this one, then we can find out its answer very easily. How? X square minus 5x plus 6 is a second degree equation, so we can factorize this quadratic equation into two monomials. Okay, x square, therefore x when we multiply x square. Okay, then we have to find a number here and another number here, so we have to think about these two numbers. So which are the numbers? The product of these two numbers will get or will become what? This 6, and whose sum will become minus 5. When we add these two numbers, we will get what? Minus 5. Such numbers are what? Minus 3 and minus 2. What about minus 3 plus minus 2? Clearly it is minus 5. So what about minus 3 into minus 2? That is plus 6. So the numbers to be fixed here are what? Minus 3 and minus 2. Okay, equal to 0. So x minus 3 equal to 0, which means what? X equal to 3. Similarly, x minus 2 equal to 0, which means what? X equal to 2. So answers are 3 and 2. The same answer will be obtained by doing quadratic equation formula. So answers are what? 3 and 2, or 2 and 3. Okay. The seventh question, x such that x is a positive divisor of 6. Okay, so as we discussed in the first page, 6 can be factorized as 1 into 6 or 2 into 3. So which are the factors? 1, 2, 3 and 6. 1, 2, 3 and 6. So this is a set corresponding to this rule form or set builder form. Right, this is Rorschach form, this is rule method or set builder method. Right. Another question, x such that x belongs to z or integer mod x less than 3. What about mod x? Mod x less than 3 means x less than positive 3 or x greater than minus 3. This is the actual definition of mod x. This is to be learned by heart. Okay, mod x means inside this symbol, modular symbol, there may be negative values or positive values. So these negative and positive values can be taken separately as this one. So mod x less than 3 detailed what x less than plus 3 or x greater than minus 3. Then what about mod x less than 10, x less than plus 10 or x greater than minus 10. On the same way, this can be splitted on the form this x less than plus 3, x greater than minus 3. So from minus 3 to plus 3 we can consider a number line minus 3 to plus 3, and mod x less than 3. So minus 3 and plus 3 are excluded. Minus 3 and plus 3 are avoided. So which are the remaining numbers? Minus 2, minus 1, 0, 1, 2. So that is a set. Okay. Similarly, A is equal to set x such that x is a prime number less than 7. Write A in the Rosher form that we have discussed in the first page. Okay, 2, 3, 5. These are the prime numbers. Prime numbers are the numbers whose factors are only 1 and the same number. So 2, 3 and 5 are the prime numbers under 7. Okay, 6 is not included here because 6 can be factorized as 2 into 3. Okay, 2 into 3. So prime numbers are the numbers whose factors are only 1 and the same number. So 6 is not included. So this much is the answer. A is equal to set 2, 3, 5. Then write power set of A. What do we mean by power set of A? Set of all subsets of A. Here A is this one, 2, 3, 5. So you can take a single set as set 2, okay, set 3, set 5, then set 2, 3, set 3, 5, set 2, 5, okay, then the whole set 2, 3, 5, then empty set. Then set of these subsets are called as what? Power set. How many subsets? There will be 8 subsets. That is 2 raised to 3 form. Okay, there are 3 elements. Therefore, 2 raised to 3 elements will be there in the power set. 1, 2, 3, 4, 5, 6, 7, 8. Okay, these subsets are the small subsets. Okay, but this is the equal subset for this one. Okay, to set 2, 3, 5. So this 2, 3, 5 set 2, 3, 5 is called as what? Improper subset, which we had learned in our first year class. Okay, 2, 3, 5. Okay, so anyway, here question is asked to find out the power set of A. So this is the answer. Okay, yes, in this question write the number of proper subsets of A. So we have seen that there are 8 elements in the power set. Okay, and out of which only one improper subset, that is a set which is same as capital A, and only one set is there, and that set is called as improper subset. Then remaining 7 subsets are what? Proper. Only one is improper, only all others are proper. So how many proper? 7. Okay, and there is a formula to find out the number of proper subsets, which is what? 2 raised to 8 minus 1. So this formula is to be learned by heart. And the number of proper subsets of A, where the number of elements of set A is n. Suppose there is a set capital A and this capital A has n elements. Then what about number of proper subsets? 2 raised to n minus 1. So 2 cube minus 1. Okay, that is 8 minus 1, 7. So there is no need of taking this formula, but we have to answer this question very simply, because in a set having 4 elements, then there will be 2 raised to 4 elements in its power set. 2 raised to 4 means what? 16. So number of improper subset means only one, which is the same set. All others are proper. So 16 minus 1, 15 proper subsets will be there. Okay, so here answer is 7. See this question. A is equal to set x such that x is an integer minus 1 by 2 less than x less than 9 by 2. That is here. A is from minus 1 by 2 to 9 by 2. Okay, minus 1 by 2 is here, 9 bit means 4.5, that is here. So which are the numbers? 0, 1, 2, 3, 4. Okay, 0, 1, 2, 3, 4. So that is A. So its answer is this one, 0, 1, 2, 3, 4. Similarly, B is equal to set x such that x belongs to n, 2 less than x less than or equal to 5. So from 2 to 5. Here 5 is included. There is no underscore, therefore 2 is not included. Okay, 2 is excluded. So which are the numbers? 3, 4 and 5. So that is all about B. 3, 4, 5. So A and B are obtained. Verify that A union B difference A intersection B equal to A difference B union B difference A. So we have to prove this result. First we are going to find A union B, then we will find A intersection B, then we will find its difference. Okay, so that is all about left hand side. Similarly, we will calculate right hand side, then we will ensure that both left and right sides are same. Okay, for that, firstly we are taking A union B. So A is this one, B is this one. What about A union B? Combining up of elements of these two sets. That is 0, 1, 2, 3, 4, then 5 also. Okay, in a set elements are not to be repeated. Okay, so when we combining up of the elements of these two sets 0, 1, 2, 3, 4, 3, 4, 5, then 3 and 4 will be repeated, that is to be avoided. So which are the elements in A will be 0, 1, 2, 3, 4, then 5. Okay, 0, 1, 2, 3, 4, then 5. Then what about intersection A intersection B? 0, 1, 2, 3, 4, 3, 4, 5. They are common elements. Which are the common elements? 3 and 4. Okay, 3 and 4 are the common elements. Therefore A intersection B is what? Set 3, 4. Set 3, 4. Okay, then what about A union B difference A intersection B? A union B is what? This one. Okay, A intersection B is what? 3, 4. Okay, so we have to eliminate these elements from here. So you delete 3 and 4 from here, 3 and 4 from here. Then which are the remaining parts? 0, 1, 2 and 5. 0, 1, 2 and 5. So this is the answer for this left hand side. A union B difference A intersection B. Then what about for right hand side? A difference B union B difference A. What about A difference B? A difference B, what is A? 0, 1, 2, 3, 4. Difference, what is B? 3, 4, 5. So you have to eliminate these elements from here. So 3 is to be eliminated, 4 is also to be eliminated. Okay, there is no work for this 5 because 5 is not here. So only 3 and 4 are to be eliminated. So which are the remaining? 0, 1, 2. So answer is 0, 1, 2. Okay, then what about B difference A? B difference A is equal to B means set 3, 4, 5. Difference A means 0, 1, 2, 3, 4. So which are to be eliminated? 3, 4 here, 3, 4 here. So 3 and 4 are to be eliminated. So when we eliminate 3, 4 from here, so only element is 5. So set to 5 is the answer. Okay, so A difference B is obtained and B difference A is also obtained. So question says about what? Their union. A difference B union B difference A. A difference B union B difference A is equal to what? A difference B means this one, B difference A is this one. So their union means what? They are combining up 0, 1, 2, 5, 0, 1, 2, 5. So look at these LHS and RHS. So they are same. Therefore our result is proved. Okay, so that is all about this question. We proved this result. Both left and right sides are same. Okay. Then what about this question? Question number 4. U, which means universal set, big set. So under this, for this question, this U can be taken as a universal set for this question. U is equal to set X such that X belongs to W. What is W? Set of whole numbers. What are whole numbers? The numbers from 0. Okay, 0, 1, 2, 3, 4, etc. These are the whole numbers. No negatives are included, no decimal numbers are included. So X means set of X means whole numbers under 6, including 6. Okay, 6 is included. So which is the answer? 0, 1, 2, 3, 4, 5, 6. Here underscore, therefore 6 is included. and A is also given as x such that x is a prime divisor of 6. So which are the divisors of 6? 1. Okay, 1 into 6, 6. Okay, 1, 6. Then 2 into 3 equal to 6. So 1, 2, 3, 6. These are the divisors of 6. 1, 2, 3, 6. From here, which are the prime numbers? 2 and 3 only. Okay, 2 and 3 are the prime numbers as divisors of 6. Okay, so A is equal to 2, 3. Then B is also given as set 1, 2, 5. 1, 2, 5. Then we have to verify De Morgan's law. So what are De Morgan's law? These are De Morgan's law. A union B whole complement is equal to A complement intersection B complement. Similarly, A intersection B complement is equal to what? A complement union B complement. So here symbols are changed. Okay, when here union, here will be intersection. So if when it is intersection, it will be what? Union. So learn this formula by heart as De Morgan's laws. Okay, for that, to prove A union B whole complement, we have to find A union B. Here A is 2, 3, B is 1, 2, 5. Then A union B can be calculated. Okay, then A union B whole complement means what? So A union elements of A union B are to be eliminated from this U. That is from this U. Okay, let us check that. Similarly, A complement intersection B complement. So for this, we have to calculate A complement and B complement. What is A complement? A complement means set of elements of universal set other than A. So we have to eliminate elements of A from this U. What is U? This one. Okay. What is A? This one. So A complement means this step. Okay, U difference 2, 3. So you have to eliminate 2 and 3. So you have to eliminate 2 and 3. Then which are the remaining 0, 1, 4, 5, 6. So complement means what? A complement means eliminate the elements of A from the universal set. So universal set is explained under the term complement of a set. So to understand complement of a set, we have to learn about universal set. Okay, so A complement means U difference A. Similarly, what is B complement? U difference B. Okay. Yes, what is B complement? This one, U difference B. What is U? 0, 1, 2, 3, 4, 5, 6. And B is this one in the previous page. So eliminate 1, 2, 5 from there. 1, 2, 5. So which are the remaining? 0, 3, 4 and 6. Okay. Hence we have got A complement and a B complement. So we are going to prove De Morgan's law. First law is what? A union B whole complement is equal to A complement intersection B complement. Okay. So let us take left side A union B whole complement. Further, firstly we are finding A union B. A union B means what? A is this one, B is this one. So combining of the elements of A and B, that's 1, 2, 3, 5. All elements 1, 2, 3, 5. Then what about A union B whole complement? That is U difference A union B. Complement is defined under universal set. Okay. So A union B whole complement means what? U difference A union B. U is this one. A union B is this one. So eliminate 1, 2, 3, 5 from there. 1, 2, 3, 5 from there. So we obtain 0, 4, 6. 0, 4, 6. So A union B whole complement is equal to set 0, 4, 6. So that is all about left hand side. Similarly, what about right hand side? A complement intersection B complement. Okay. A complement intersection B complement. So we have seen A complement in the previous page 0, 1, 4, 5, 6 intersection. What's B complement? B complement is 0, 3, 4, 6. Okay. Then what about the common? 0 is common. 4 and 6 are also common. 0, 4, 6. Okay. So comparing these two answers, LHS and RHS, they are same. Therefore, first De Morgan's law is verified. Okay. Similarly, what about the second law of De Morgan's theorem? A intersection B whole complement is equal to A complement union B complement. So further, firstly we are finding A intersection B, which is a common part of common set of both A and B. Here A is this one, B is this one. Clearly A intersection B is at 2. Then what about its complement? U difference A intersection B. So answer is this one. So that is all about left hand side. See, A intersection B complement means what? A intersection B complement is equal to U difference A intersection B. So you will get this step and hence this answer. Then what about right hand side? Right hand side means A complement union B complement. Okay, A complement is obtained from previous page as this one, and B complement is from this page. That is what B complement 0, 3, 4, 6. Okay, 0, 4, 3, 6 or 0, 3, 4, 6. Right. Then what about its union? 0, 1, 3, 4, 5, 6. Right. So compare these two answers, they are same, and hence both left and right sides are same. Okay. Then very important question, fifth question. In a group of students, 100 know Hindi, 50 know English, and 33 know both. Each of the students know Hindi or English. How many students are there in the group? So suppose there are some students, and from these students 100 know Hindi. Okay, 100 know Hindi. We don't know how many students are there. Suppose there are a lot of students, and from these students 100 students know Hindi. Okay, 50 students know English, and 33 know both languages. Right. Okay, then each student know Hindi or English. So there are students having the knowledge of Hindi or English. Some of them have both knowledges or both languages, and sometimes there are students having only one language. Anyway, so we don't know about the question. So question is asked to find out how many students are there in the group. Okay, so for that we are using the figure for this question, and such figures are called as Venn diagram. Okay, yes, Venn diagram. There are two sets. For one is for Hindi and other for English. Right. H means the set of students know Hindi. H and this E for English. Question says that there are 33 students having both languages. So 33 for both means the intersection. Okay, 33. And the question again says that there are 100 students having Hindi. Okay, what about 67 plus 33? 100. So here 33 is present here because 33 is common. So remaining part means 67. This is from our logic. We have to think about the 67. Okay, then whose sum will be what? 100. 67 plus 33, 100, and hence the number of students having Hindi language. Okay, similarly, number of students knowing English language means 50. Okay, 33 is present here. Then what about remaining 17? This is from our mind. Okay, 70. 33 plus 17, 50. So how many students are there? 67 plus 33 plus 17. So answer is 117. Okay. So this is a very simple step to calculate the answer, and this is an algebraic expression by using the formula. Here n of h means number of students having Hindi, that is 100. It is 50 for English. Okay, this is common. N of E intersection h 33. So we have a formula. N of A union B is equal to N of A plus N of B minus N of A intersection B. N of A union B is equal to N of A plus N of B minus N of A intersection B. Instead of A, we can take English or Hindi. Okay, English. N of B, that is Hindi. So N of A E plus N of H minus N of E intersection H. This is not A but E. n of e intersection h. So n of e means what? 50 for English. N of h means what? Hindi, that is for 100. N of common a intersection h means 33. So final answer is 117. I think this is very simple step, right? Another question. In a survey of 400 students, 100 like apple juice, 150 like orange juice, and 75 like both. How many students like neither apple juice nor orange juice? So by reading this question, we have to think that there are some students having no idea about apple juice or orange juice, isn't it? Because question says that there are some students like neither apple juice nor orange juice. So there are some students without having apple juice or orange juice. So for that we are drawing a Venn diagram, and this box is drawn here, but in the previous question this type of box is not drawn, because what, in that question there are no students remaining. So there are no students other than Hindi language or English language. Okay, in the group of students, all students are from English and Hindi category. So there is nothing said about other languages. But for this question, situation is different, because this question says about apple juice or orange juice. There are some students like apple juice and some students like orange juice, and there are some students without having both apple and oranges. Okay, orange juices. Here A is a set and B is another set. A for apple juice and B for orange juice. How many students like apple juice? 100, and 150 orange, common 75. So we always fill common first, the 75. Apple 100, so 25 is further needed, so that the sum will be 100. Similarly, for orange juice, how many? 150. So 75 is present. So remaining 75, so that the sum will be what? 150, right? Okay. So how many students are there here who like both either apple or orange juice? 25 plus 75 plus 75. Okay, so answer is 175, right? 175 is the answer. Which answer? Number of students having either orange or apple juices, 175. But the question says that there are 400 students. Okay, so there are some students without having these two types of juices. How many students? 400 minus 175, that is 225. That is the answer, 225. This 225 cannot be included in either of the sets A and B. So this 225 is outside these two circles. Okay, to represent this 225 we draw a box. Okay, so in the previous question this type of box is not needed, right? So answer is 225. Similarly, next question, A is a part of B. Okay, so all elements of A can be seen in the set B. A is small, B is big. Okay, for example, A is 3, 4, A is small, B is big, 1, 2, 3, 4. All elements of A can be seen in the set B. Okay, 3, 4 here, 3, 4 is also here, 3, 4 are also here. So A is a part of B, or A is a subset of B. Then what about A intersection B? A intersection B. What about A intersection B? A intersection B means common for both A and B. 3, 4. Okay, 3, 4 is a common. What is 3, 4? Set A itself. So when A is a part of B, A intersection B is always A. Here capital A. A intersection B is always capital A. So this is a formula. So you have to write here what? Capital A. A. Right. This is its Venn diagram. A is small, B is big. So A can be seen inside B. So their common part means what? A. Okay, A. So that is all about this question. Then what about 8th question? N of A is equal to 5. In the set capital A there are 5 elements. For example, 1, 2, 3, 4, 5. In the set B there are 4 elements. 1, 2, 3, 4. Okay. find n of a difference b if a and b are disjoint disjoint sets. Disjoint set means what? There are no common part. Okay, so they are separate sets. They do not meet together. Okay, A is here, B is separately drawn here. You can't draw like this. Okay, because what? Disjoint, not joint, joint, not joint. Okay, disjoint A and B. Then n of A is equal to 5, n of B is equal to 4. What is n of A difference B? A difference B means you can eliminate 6, 7, 8, 9 from here. So there is no need of eliminating because the 6, 7, 8, 9 are not present in the set capital A. Therefore, final answer is the same, 1, 2, 3, 4, 5, A itself. So A difference B is A itself. Then number of A difference B means what? Number of elements in the set capital A, which is what? 1, 2, 3, 4, 5. So answer is 5. Right. Then ninth question and the last question. The number of proper subsets of the set is 15. For the number of elements of the set. Okay, the number of proper subset of set is 15. That's given. We have the formula in previous page, in the first or second page. Number of proper subsets means what? 2 raised to n minus 1, which is what? 15. So 2 raised to n is equal to 15 plus 1, that is 16. So 2 raised to n is equal to 16. 16 can be factorized. 2 because 2 raised to 4. 2 into 2 into 2 into 2. That is 16. So 16 means 2 raised to 4. So this 16 can be expressed as 2 raised to 4. That is 2 raised to n is equal to 2 raised to 4. So these 2 can be cancelled. Therefore n is equal to 4. So that is all about the number of elements of the set capital A. Okay. So that is all about the important part from the first chapter, sets. Okay, thank you for watching.